EnterpriseNG. Thank you for watching our presentation. I'm Gleb Bahmutov, Senior Director of Engineering at Mercari US. With me is my friend Andrae Ambrose. Andrae, how are you doing today?
I'm wonderful. How are you, Gleb?
I'm doing excellent. Thank you. Where do you work, Andrae?
Well, I'm a software developer at Breebug, and I'm just so happy to be here at the conference, man. I'm really excited about testing.
I'm glad that we're talking about testing. And
Yes.
You know how I want to introduce our presentation? With my friend, artist 50 Cent, of course.
Okay. I see you, Gleb.
It makes sense. It makes sense. I'll explain. In 2009, 50 Cent asked 21 questions about relationship on his album Get Rich or Die Trying, which definitely describes my career. And the fun fact about that song that became very popular is that he actually asked 18 questions, and a second rapper, Nate Dogg, asked 4 more. So in reality, the song covered 22 questions.
Really?
Well, due to the time constraints, we only have time to ask and answer 10 questions about testing.
Gotcha. So did you actually count how many questions were asked in that song?
I had that link, Sean. They actually counted and highlighted, so I believe them.
Okay.
But I guarantee you that our talk today will cover 10 questions about testing, both basics and, I think, a little bit of more advanced topics. Yeah. So, shall we?
Let's roll. I'm ready.
The first thing that we want to answer is, what is a test really? And I'll give you my definition. A test is an independent confirmation. If you perform action X, you will get Y. For example, if you sum 2 and 3 together, you should get 5. If you find a button submit on a page and click on it, a message success with exclamation point should become visible. Now, the independent part is very, very important here. For example, you cannot say a sum of 2 and 3 should equal sum of 4 and 1, where you call the same code and check the result, because the sum could be completely broken. We see it all the time when we write end-to-end tests, for example. We see this conditional logic where we look at the page and we use the page to compute expected results, and that is not independent confirmation. It's easy to get everything wrong, and you will never fail the test, but it will be broken. Now, the one thing that I want to stress is that if you perform action X and you get result Y, like adding 2 numbers, what happens if you try to perform something else? Can the test guarantee that something else will be correct? So if sum of 2 and 3 gives you 5, then I think the chances are highly likely that sum of 200 and 300 will be equal to 500. But if you try to add -2 to -3, well, now you're kind of far away from the tested case. It might be -5 or might not be. And you cannot say anything about the edge cases. What happens if you add or sum 2 strings? Do you get the string 5 all of a sudden? No one can tell. What about edge case like passing just a single parameter? No one knows. The application could crash, could throw an error, or it might return 2 undefined, like JavaScript does in many cases. So the assumption is that if your test closely resembles and matches what the user does in real life, that then when the user repeats the same steps, the chances are high that the application will behave as expected. The test doesn't guarantee the application is correct, but it tells you that if you follow the same footprints, you'll end up in the same approximate spot.
That's good.
Now, where should the test live? Andrae, do you ever ask yourself, where should I write my tests? Is it should be with a code, in a separate repo, or use some kind of no-code solution? What do you think?
I'm going to say with the code.
You're not the only one, brother. You're not the only one. I say, if you keep your test with the code, it's 0 friction, right? You change the code, you change the test. You have to change the test, otherwise they'll always fail. If you commit the code, it will commit the test as well. So they always go hand in hand. Now, it does require extra tooling because you're adding test runners, you might add TypeScript definitions, you might add additional commands, it might increase installation time. So it definitely has its downside. Yeah. So I suggest that if you're just trying to bring better testing or a new testing tool into your organization, put it in a separate repo. It's fine. It's a good way to start tests, but with time, you will find yourself maintaining the tests more and more. Now, regarding the option C, no code testing solutions, right? All the things that are codeless. I don't know about them. I've never seen a successful example yet where people adopted it and use it for a long time. So I definitely cannot say that that's a good way. Now, a common question that I will ask and people ask is, how long should a good test be? And I'll say that, yeah, it's like unit tests are short, right? Like they follow this pattern where you arrange the code, right? Like you import some from your module, then you act. You call it with 2 and 3 arguments, and then you assert that result is 5. Now, this is unit test. But for end-to-end tests, for example, it's fine for tests to be longer because they should be meaningful. They should really show how the user is performing something on a page and go through the whole user story as shown right here, where we create things. The good thing is that a modern test runner captures a video, allows you to debug it. So it's not a problem writing longer tests. Well, sometimes the test becomes too long, right? It becomes slow. And in that case, I suggest that you think how to optimize it, how to split it up. For example, if your test goes from page, filling each page, and then goes to the next one, and it has to fill a lot of form just to submit it and confirm the result, I suggest you split it up. Here's one example how you can do it. You take this long test and you split it into 3 tests. Each test has a checkpoint at the end. And then the second and third test, they start from the checkpoint. And modern applications have a way of doing this. You usually have some kind of internal state. So if you finish the test, you confirm that application finished in that state. And at the start of the second test, you set the state again, because you know the first test finished it. And now you start the second test with that state object, and you continue from that moment because application doesn't care. It thinks it went through the first page completely, and now it transitioned. So to me, a good long test can be split up almost like a relay, where each test starts where the last test has finished.
That's good. Very good. So the question I get asked is, who should be writing tests? Yeah. And a lot of developers feel like we have a QA department and they should be handling all of the testing. But I am of the opinion that developers should be writing their own tests. It's just a good way to ensure that we are delivering quality code. Now, there are some teams that do have SDETs, that's software development engineers in test, and they are responsible for the testing suites. However, that does not negate the fact that you as a developer should be testing your own code. What do you think about that, Gleb?
You know, nobody wants to do extra work, right? And if you come in and you say, hey, you're developing something and you also have to write this longer tests, right? Think about edge cases. I will definitely complain and I will try to avoid, right? I think in a big organization, you definitely want the person who is familiar with code, right? Can update the test, modify the code to be more testable, to be writing the test as we work on a feature, right? But I agree. Yeah, it's complicated and you have to convince people, right?
Absolutely. Absolutely. Now, there's another question that comes up here. Let me see if I can get over to the next question. And it is, when should you run your tests? Well,
once in a blue moon, I say.
No, I believe that a developer should run their own tests on every commit or every PR. You want to know immediately if you broke something accidentally. I believe that you are to test early and test often. And if you adopt that philosophy, it'll drastically improve the quality of your software. Testing early and testing often saves us time and effort. If we do not find defects early in the development cycle, it's going to get more complicated and harder for us to discover defects down the road. We're going to have to put a lot of effort and time into diving into the code and finding out where's the bottleneck. So testing early and often saves us time and effort, but it also gives us a better chance at meeting deadlines. If we are catching defects faster, then we have time to fix them and we're able to meet the deadline. So testing early and often is the way to go.
100%.
Yeah. There's another question that comes up. What are the signs of a bad test? Dun, dun, dun.
Andrae, it's like the signs of bad developer, right?
Most certainly. So number one, I have 3 points. Number one, repetition. We want to look for opportunities to dry our code. Do not repeat yourself. We've heard that as developers over the years. So we want to look for those opportunities to dry our code. You can see here in our code sample that we have a custom command that contains multiple selectors with the same assertion. And in order to dry our code in this case, we can move the selectors into an array and use a for each method, which calls the provided callback function once for each element in the array. So we have just dried up our code and have made it more efficient. Now, there's another point there's another sign rather of a bad test, and that's a highly brittle.
Yeah, go down.
Highly brittle selectors that are subject to change. So what we don't want to do is we don't want to target elements based on CSS attributes. We don't want to target elements that may change, their text content. And on the left here, you'll see that we have a button element with multiple attributes. And the best way to target this element is to add a data test ID or a data-sci attribute to the element. And that gives us a targeted selector that's only used for testing. And this is the best way to implement solid selectors and creating solid tests. And then there's one more sign of a bad test. If we can go down one more. There we go. Inconsistent results. Yes. Oof. If you run your test multiple times and you get different results every time, then that could possibly be a sign of a flaky test. And we don't like a flaky test.
Because everyone stops paying attention to the fail test then, right? Because they assume if you run it, it will just pass.
Yeah.
So,
certainly.
Well, Andrae, at the end of the day, do you think you have confidence in your tests?
Oh, yeah, I'm perfect. I'll write perfect code.
You asked me the same question, right? Like, can you explain, like, how do you know that you have confidence at the end of the day? And I think when you deploy, you have to ask yourself 2 questions. What do you still test manually? Because if there is something that you check out after the deployment has finished, right, maybe part of application, then you don't trust the test in that particular area. So you lack confidence. On the other hand, look at the bugs that you missed, because maybe you had confidence in your test and it was misplaced. Your test actually missed it. Now, it might be unfair, right? You can have different sources of bugs, right? It could be something completely unforeseen, something you could not test easily, like performance regressions and so on. Maybe a new browser version, right? But look at those 2 questions. Ask yourself, do I trust my test, or do I actually check something manually after deploy, and what did I miss? And that's what gives, is a sign of confidence in your tests.
Yes. Next question. Should you retry your tests on failure?
And Andrae, you mean the automatic retries, right?
Yes. Yes. Automated retries. And this is a serious decision, something we don't take lightly. And the answer is yes and no. Yes.
I don't think it's
no.
a good answer. I don't think it's a good answer.
Well, here's the deal.
Yeah.
It's important to know why your test failed, because each failure or each issue requires a different approach. So a test can fail for different reasons. You could have an app that didn't properly render. You could have an HTTP request that wasn't fired or timed out, or the staging server was down, and that's why the test failed. Now, if your staging server fails, chances are you're going to rerun the test again, and there's not going to be much of an issue.
Yeah.
Okay. But if you discover that you have timing issues with your tests, like you didn't wait for an element to render, or you didn't wait for a page to load, you should fix those timing issues. And not resolving those timing issues causes you to have flaky tests. And we don't want flaky tests. So should you retry your tests on failures? Yes and no. Yes, retries should be used to discover why the tests failed. But no, retries should not be used to camouflage flaky tests.
Right. Right. Now, here's a question that bound to have some controversy. How do you pick a best test runner for your team?
Flip a coin.
Flip of coins is probably a better way than what I've seen. I've seen like tool X versus tool Y, and where we're like, okay, here's a simple test like 2 + 2, or visit a page. It finishes in 2 seconds versus 4 seconds. Like, no. To me, all these comparisons are a huge red flag, but you don't actually understand what the effort it takes to be successfully using a tool. For example, installation of a tool, starting with, using a tool requires a lot of effort. You should compare, tools by that. Writing tests takes part of the effort, right? Some tools are optimized for different types of testing, so it makes it easier to write tests. Running tests is what people usually compare test runners on, but to me, it's like smallest part of the effort, because the debugging a failed test, that's where you actually spend expensive development time.
Yes.
Maintaining the test, that's where you spend effort and expensive QA time. So you have to compare across all these bars. Well, to me, the effort for installation writing test depends on how well the tool is described and on the experience you had with that tool. Running tests, how long it takes, it all depends on your CI setup. If you can parallelize your tests, that's it. They'll be fast. The real difference, I believe, is between the test runners comes in how easy it is to debug a failing test and how easy it is to maintain and change the test if you need to. So a few examples. No test, just manual, right? Everything is easy. Everything is super fast, except if you have to change a test or a feature, that's it. You will suffer. If you have manual tests only, running them takes a lot of effort. Debugging a failing test, you have to remember how it's supposed to work. I worked at Cypress for a long time, so I'm partial to the tool. I think, running test takes a little bit longer, but our bars are very low. Now, if you actually use Cypress following my advice and Andre's experience, everything is nice and easy. I'm not going to say anything about this slide, but I'll say my principles, right? Every test runner and all your testing initiatives require effort. So think of a matrix where each column is how much effort you put in every iteration, every sprint. And then think about the confidence you gain from those testing efforts. You do want to pick the tools and change the tools depending on what you observe in your team. So you move from red to green. And once you end up in low effort, high confidence state, that's where you want to be.
Yeah. Well, this question here gets asked a lot. How do you push for more testing? it is challenging at times to get people to see the value of testing. I have been there, well, most certainly. But I firmly believe that if you are convincing or trying to convince your upper management to push or implement more testing, put budgets behind testing, you have to speak the language of upper management, because upper management speaks the language of metrics and money. Yeah. So speaking in terms of metrics allows management to be presented with the hard facts about how low quality software impacts the business's customer base and its brand image. Yeah. If projects are consistently late, if they're over budget, or if the software is buggy, this impacts the company's reputation. Yeah. Now, speaking in terms of money allows management to see how neglecting to implement poor testing can be fiscally irresponsible and can cost the company more money in the long run. Now, upper management isn't the only group that you may have to convince to, push more testing through. You also sometimes have to convince developers, because sometimes we don't have the time. Writing tests, it's a menial task, but sometimes, in order for us to push developers that way, training yes. greatly helps. Training how to write good tests. Also, if you can set up a good framework. Now you say, what do you mean by a good framework? We have frameworks. Well, sometimes implementing helper methods could most certainly help developers, continue to write tests. It can encourage them to write tests. It's easier for them. It's easier to convince them to write tests. And then also good documentation will also help kind of push for good testing, push the organization in the realm of good testing. So you have to highlight how testing is a vital part of delivering high quality software.
I just love this phrase, right? If you don't have good tests, your users will be your testers, right? So don't let your users test your application. Will Klein said it in his presentation, and I definitely agree. It will cost you money ultimately if you allow the users to be your tests.
That's good. This is one of my favorite quotes here regarding testing. Can the slide switch? There we go. This is by Michael Bolton, the author of Rapid Software Testing. It says the problem is not that testing is the bottleneck. The problem is that you don't know what's in the bottle. That's a problem that testing addresses. That is a great quote. Great quote. Well, I think we've come to the end of this presentation, Gleb. And we'll say thank you, guys. We did it. I hope that you were greatly informed and encouraged to test. We are on Twitter. You can reach both Gleb and myself on Twitter. Just if you have further questions, just go ahead and reach out to us. Thank you again so much for having us, and we hope to see you guys soon.
Thank you. Take care.
Hi, I'm Joe Weems. Thanks for checking out this video from EnterpriseNG 2021. Online conferences were great, but it's time to get back in person. See your old friends, make some new ones, and take your career to the next level. Head over to ng-conf.org to get your ticket. See you there.